topic of my presentation is AC fundamentals, and in it I am going to explain them briefly. So let us start with its definition. AC fundamentals are necessary to analyze the networks consisting of various alternating current and voltage sources, resistances, and inductive, capacitive reactance. An alternating current or voltage is the one which changes periodically both in magnitude and direction. Each cycle of AC fundamentals consists of two half cycles, namely positive cycle and negative cycle. Current increases in magnitude in one particular direction, attains maximum and starts decreasing. Passing through zero, it increases in opposite direction and behaves similarly. Main AC fundamentals are generation of alternating voltages and currents. Alternate method for the equations of alternating voltages and currents. Simple waveforms. Cycle. Different forms of E to M to F equation. Phase. Phase difference. Root mean square, RMS value. Average value. Form factor. Crest or peak factor. An alternating current AC continuously reverses direction, alternately flowing in one direction and then in the other. Alternating voltage can be similarly described. Usually, AC voltages and currents are sinusoidal and definite relationships exist among the peak, average, and effective values. Turbine-based AC electrical generation is when an electric current is induced by the interaction between charged particles and magnetic fields, which converts the kinetic energy of the turbine into the kinetic energy of electrons. Three-phase electrical generation is very common. The simplest way is to use three separate coils in the generator stator, physically offset by an angle of 120 degrees, 1/3 of a complete 360 degrees phase, to each other. Three current waveforms are produced that are equal in magnitude and 120 degrees out of phase to each other. Alternating voltage may be generated by rotating a coil in a magnetic field, or by rotating a magnetic field within a stationary coil. The value of the voltage generated depends upon the number of turns in the coil, strength of the field, and the speed at which the coil or magnetic field rotates. Alternating voltage may be generated in either of the two ways, but rotating field method is the one which is mostly used in practice. Equations of AC voltages and currents are shown here that we can calculate them easily with these equations. The shape of the curve obtained by plotting the instantaneous values of voltage or current as the ordinate against time as a abscissa is called its waveform or wave shape. Or an alternating current or voltage is one the circuit direction of which reverses at regularly recurring intervals. Now, what is AC cycle? Alternating current AC is a flow of electric charge that periodically reverses. It starts from zero, grows to a maximum, decreases to zero, reverses, reaches a maximum in the opposite direction, returns again to the original value, and repeats this cycle indefinitely. The time it takes for one complete cycle of an alternating current AC signal is called the period. The unit of measurement for the period is seconds, s. Therefore, the period of an AC is the time taken by it to complete one cycle. The time taken by an alternating quantity to complete one cycle is called its time period t. The number of cycles/second is called the frequency of the alternating quantity. Its unit is Hertz.or. The frequency of an AC wave is the number of cycles that occur per second. And its formula for it is shown. By phase of an alternating current is meant the fraction of the time period of that alternating current which has elapsed since the current last passed through the zero position of reference. Or, in AC circuits, phase refers to the relationship between the voltage and current in a circuit. The phase of an AC wave is the fraction of a cycle that has elapsed relative to a reference point. If we consider three similar single-turn coils displaced from each other by angles A and B and rotating in a uniform magnetic field with the same angular velocity, the value of induced EMF in the three coils are the same, but there is one important difference. The EMF in these coils do not reach their maximum or zero values simultaneously, but one after another. This deficiency is supplied by using the terms lag or a lead. A leading alternating quantity is one which reaches its maximum or zero value earlier as compared to the other quantity. The RMS value of alternating current is given by direct current, which flows through a resistance. The RMS value of AC is greater than the average value. The root mean square value of sine current wave can be determined by the area covered in half cycle. The root mean square value of an AC current is defined as the steady or DC current, which when flowing through a circuit for a given time period produces the same heat as produced by the AC current flowing through the same circuit for the same time period. RMS value is also known as effective value or virtual value of AC current. The average value is defined as the value of DC current which would transfer the same amount of charge across any point of circuit as is transferred by the AC current for the same time period. The average value of sinusoidal alternating voltage or current over one cycle is 0. The average value of AC sinusoidal current or voltage is equal to 0.637 times its peak value. The formula for calculating the average value of AC current or voltage is average value equals 0.637x peak value. The form factor of an AC waveform is defined as the ratio of its RMS, root mean square, value to its average value E. It identifies the ratio of the direct current of equal power relative to the given alternating current. For a sinusoidal or complex waveform, the form factor is given as form factor equals RMS value / average value equals pi / 2 square root 2 is almost equal to 1.11. Square-shaped waveforms always have crest and form factors equal to 1, since the peak is the same as the RMS and average values. And in the end, the crest factor of an AC waveform is defined as the ratio of its peak value to its RMS, root mean square, value. It is a parameter of a waveform that shows the ratio of peak values to the effective value. In other words, it indicates how extreme the peaks are in a waveform. The crest factor of an AC waveform is always greater than or equal to 1 and can be calculated by given formula. Thanks for watching. That's all for today's video on AC fundamentals. I hope you found it useful and interesting. I welcome your suggestions in comment box on what topic you want me to cover. If you want to see more videos like this, please subscribe my channel and click the bell icon to get notified whenever I upload a new video. Never forget to like and share.